So your fundamental theorem of calculus, pretty important. If f is a continuous function, and I don't like how they do this, but I went with it because it's how it's written in like every textbook. And if you look online, it's written that way. They use lowercase f for the function. And then capital F is the antiderivative. Remember us doing that last time and we did it on the quiz review, go backwards. If capital F is the antiderivative on your interval a to b, then your integral from a to b of lowercase f of x dx equals, and here's where you've done an antiderivative, so now it's going to be capital F. It's f of b minus f of a. It's the upper boundary minus the lower boundary. Let's review. Derivative means slope. Integral means area. What you are finding is the area without having to draw a picture. You know, in the quiz review we just did, I just drew the graph and we found the area. Well, what if it's not a nice shape like a trapezoid or a triangle or a rectangle? What if it's something curved? Then you would need to do this. So this is how you can do it without a calculator and without having to draw a picture. And sometimes a picture won't help you anyway. Right, so it's upper boundary minus lower boundary. So looking at this first one, and if you remember back to when I taught you the Riemann sums, I know that was a few days ago at this point. This is the problem that we did. This is how I introduced it. That's why I have this as the first one. What is your antiderivative for x squared? I'm going to go backwards. Good, you weren't even here. See, that's the lesson you missed. 1/3 x cubed. Now here's how we write it. You put a bar. The bar means such that. That's how you read it. It is a such that bar. 0 to 1. So notationally, and they will mark it wrong on the AP exam if your notation is not correct. You kind of have to be perfect. After you do the antiderivative, you don't draw the curly S anymore. You don't draw the integral symbol. You have your such that bar, right? And then it is upper boundary minus lower boundary. And I strongly recommend that you do that and put it blank and then just go and fill it in so you don't miss a negative sign or get, it's more about organization than intelligence. You just don't want to be disorganized. Do it that way, okay? So if you plug in 1 to this, you're going to plug in your upper boundary. What do you get? If you plug in 1 to your antiderivative, 1/3, good. And if you plug in 0, you get 0, and the answer is 1/3, which we did back with the Riemann sums. And I just want to review how to type it into Desmos. We're not going to use a calculator on these, but just so that you can remember how to do it. It's an integral, so you type INT, and then you can just type the whole thing in. So 0 to 1. You need parentheses, though. It won't do it without parentheses, and then dx. See how it tells you 1/3 there? Cool. Okay, we're going to just practice the heck out of that. Antiderivative of 4x. You need a function that if you did the derivative, you would get 4x. Like 4x is the answer. Get 2x squared, perfect, such that 0 to 1. And we're going to do upper boundary minus lower boundary. So fundamental theorem of calculus, upper boundary minus lower boundary. That's all it is. You're finding an area. So if you plug in 1 to your antiderivative, what are you going to get? You have 2. If you plug in 0, it's 0. And so your answer is 2. All right. Antiderivative for all of this. Well, the x squared is going to be your 1/3 x cubed plus, all right, what's your antiderivative for just x? Good, 1/2 x squared. What's your derivative for just -1? It would be minus x. Good, such that -3 to 3. Oh, and just in case if somebody, I know someone was probably thinking it, why we're not putting a plus c? Did anyone have that thought? Or no, were you just going with it? I'm glad you trust me. Do you remember how we talked about definite integrals versus indefinite integrals? These are definite. See how there's boundaries? We're getting an actual numeric answer, like 1/3 or 2, like we're finding an area. Indefinite, remember you don't have the boundaries on there, so you just throw plus c at the end because you can't get an actual answer. This is making, okay, heads nodding, I'll take it. All right, so upper boundary minus lower boundary. Please do that. Don't be too proud to just write it out blank. If you get disorganized, it gets to be kind of a big mess. All right, upper boundary. We're going to plug in 3 to this whole thing. All right, 3 cubed, 27. A third of that is 9. Cool. Plus, now if you plug in 3 here, 3 squared is 9, so that's 9 halves, or you can write 4.5. I like fractions better, so I'm going to go with 9 halves. And then if you plug in 3 to this part, minus 3. Now we're going to plug in negative 3, and it's going to come out very similarly. Negative 3 cubed would be negative 27. A third of that is negative 9. When you square something, it turns positive, so that would still be 9 halves. And then this would be minus negative 3, so plus 3. Now, some of these, if they get super ridiculous, we'll just stop and leave it alone. But this one, I mean, sometimes they make you keep going, and you have to actually, if it's multiple choice, they're not going to make that a choice. Here's what I do for that, and you can kind of battle through it however it works best for you, but here's my suggestion. I copy out the first part. Like, I'm literally just going to rewrite that. And then I distribute the negative into the second part, which means everything's just going to change its sign. And the reason why I do that, I'm not going to give you bad advice. I'm going to tell you the easiest way to do it because I want you to get the right answer. Okay. The reason why I do that is sometimes things will cancel. So that's why I do that. And it actually works out in this one. What is going to cancel out in these? Yeah, the 9 halves, which is very convenient. So that's why I do that. I kind of just take a step and rewrite the whole thing, distribute the negative sign. And lots of times, often something will cancel. So now we're just going to add it all together. Can you what does that shake out to be there? Yeah, 9 and 9 is 18. 12. Cool. This one I'm going to rewrite before we actually do the problem. How can you rewrite this term? It would be 2x to the what? Negative 2. Good. Plus x. That's just kind of a margin problem. That's just off to the side. That's like me writing my thoughts. Okay. Now we're going to do the antiderivative. You're going to add 1 to the power. It's tricky because it makes it less negative. You add, I just go like this when I'm talking about it. Get everyone to remember. Add 1. That would make this negative 1. And so you'd put a negative out front. So out front, you've got a negative 2. Plus, and then what's your antiderivative for just x? 1/2 x squared. Good. Such that 1 to 4. Now, what I'm going to do is flip my pencil over and use that nifty thing on the other end that's called an eraser and fix this because I don't want to do 4 to the negative 1. How can I rewrite this term so that it doesn't have a negative exponent? Yeah, good. The x is going to go down to the denominator. We're actually doing exponent rules in Algebra 1 right now. I call them the traitors. I say they go to the other side. That's what I call the negative exponents. All right, so upper boundary minus lower boundary. That's your fundamental theorem of calculus. Just write it out blank. We're going to plug 4 into all of this. So what do you think? If we plug in 4, what do we get for that first part? Negative 1/2 plus. All right, 4 squared is 16. Half of that's 8. And then we're going to plug 1 into this whole thing. So that would be negative 2 plus 1/2. So again, and it is up to you. Everyone thinks differently. And if you're like, no, I don't like the way you're doing it, Miss Cole, I'd rather do it my way. Fine. Like, as long as you get a right answer, I am thrilled. But what I usually do is I just copy it and distribute the negative sign. That's kind of just what works best in my brain. And this one, nothing cancels, but you can kind of combine negative 1/2 and negative 1/2 would be negative 1. And usually something convenient like that happens. So what is that going to be? 9. And remember what we're finding are what? Like, what do these answers represent? Yeah, perfect. Perfect. Because I don't want you to become little correct answer machines and just churn out these correct answers and have no idea what it is you actually did, because sometimes that's what ends up happening. All right. What I would do for this one is, do you see that 4 in the denominator? I would evict that 1/4 from the problem entirely. I'm just going to write this off to the side. 1/4 integral 1 to 4. Just took that 1/4 and took it out front. And it's x plus, how can you rewrite square root of x? so that it has a power. Like we want it to have an exponent. Or, well, did someone say it? That was a little quiet. Yeah, 1/2 is the power for a square root. What would it be for a cube root? Yeah, 1/3. Okay. So that 1/4 is going to just hang out. What you can honestly do is ignore it entirely and then just throw it back in your answer at the end, which is kind of what I'm suggesting. I would just sort of ignore the 1/4 and then like, I'm going to write it out front, but we're not going to do anything with it. All right. So what is your antiderivative for, we've done just x a bunch of times, 1/2 x squared. I'll just go ahead and tell you that one. Plus, now careful because it's a fraction. You have to add 1. It'd be x to the what? If you add 1 to that. Get 3/2, good. And so that means out front 2/3, such that 1 to 4. I kind of ran into my margin problem, I'm sorry. And I'm just going to leave that 1/4 out front, and we're going to do upper boundary minus lower boundary. As a heads up, I am not going to see this one through to the very end. Do you see how common sense wise the other ones were doable and this one's going to be like a complete mess? Like, you know, use your common sense on that. All right, so if you plug in 4 to all of this, 4 squared is 16, half of that is 8. Plus, and then what you are allowed to do is just leave it right like that, which is what I am recommending. All right, and then we're going to plug in 1. So that would just be 1/2 plus 2/3. 1 is easy because 1 to any power is just going to be 1. But this is just fine as an answer. Bless you. Like, please do nothing if it turns out to be a disaster. We're doing on time. We're doing good. We're doing good. All right. Antiderivative for 2x cubed. You want to add 1 to the power and then divide. What do we think? Yep, good. 1/2 x to the 4th minus e to the x. It's its own derivative. It's its own antiderivative, such that 1 to 3. Upper boundary minus lower boundary. I'm going to leave this one alone too, because there's just not going to be anything really that can be done with it. 3 to the 4th. You can either leave it 3 to the 4th, but say you had to evaluate that. It's 3 squared squared. If you need to do something to the 4th, just square it and then square it again. So 3 squared is, 3 squared, 9, and then 9 squared, 81. And then half of that. So 81 halves. You did cube. Your brain was in the right place. Minus, don't overthink this. It would just be what? Yeah, minus e to the 3rd. Now we're going to plug in 1. If you plug in 1, you're going to get 1/2 minus e, or e to the 1 if you want to leave the 1 in there. I'm not going to mess with that because there's really nothing I can do to make that any better. I mean, I guess you can combine the 81 halves and the 1/2, but like, what are we trying to do here? That's fun. This one's going to involve some unit circle, which I am happy to review with you. I need a function. Okay, there's only 6 of them. There's only 6 trig functions. You have a 1 in 6 chance of guessing. Hint, it's not sine or cosine. I'll give you another hint. It's negative. Which one has that as its derivative? Like, that's the answer. Which one of the other 4? Which one? Secant goes with tangent, so it's not cosecant of x, such that pi over 4 to pi over 2. It wasn't going to be secant or tangent. Those two go together. So I was hoping for either a cosecant or a cotangent as your guess. All right, so we're going to do upper boundary minus lower boundary. On your unit circle, where is pi over 2? I'm looking for a word like up, down, left, or right. Up. Good. You guys know your unit circle. Be right there. This is just me doing my, if you can do it in your head, that's cool. All right. Cosecant means you want to flip the y value. It's the reciprocal of sine. So when we do cosecant, we're going to flip the y value. If you flip 1, you get 1, only it's going to be negative. So -1. Do you remember what the sides of the triangle are for pi over 4? Nice. Good job, guys. You know your unit circle. Fantastic. I love it. If you flip square root of 2 over 2, you get square root of 2. I will go through explaining why that is if you want, but you end up with 2's everywhere and then they cancel out. So I tell everyone in pre-calc, if you flip square root of 2 over 2, you just get square root of 2. Only it's going to be negative. This one is written with words instead of a problem. Okay. Find the area bounded by these graphs. I'm just going to draw you a picture real quick. It won't take but a second. What does e to the x look like? Doesn't like swoop. All right. We want to go from 0, which would be right here, to 2, which would be right here. And then y equals 0 is, your x-axis. So we want the area of this thing. So we just have to set up the problem ourselves, but it's not going to be that hard. It would be integral from where to where. They kind of gave you everything. Yeah, from 0 to 2. And what's the function? Yeah, e to the x dx. Like, it wasn't that bad, right, guys? Like, too terrible. And the antiderivative of e to the x is e to the x. It looks like you didn't do anything, but you did. It's just itself. And then upper boundary minus lower boundary. So if you plug in 2, you just get e squared. If you plug in 0, what's e to the 0? 1. Good job, guys. This is going well. At least I feel like it is. You guys are getting quiet on me again, though. We're not going to work this one the whole way out. We'll just do the setup. We are going to need to draw a picture, unfortunately. So draw yourself a little grid off to the side. What is this graph going to look like? Like just the shape of it. Like what's it going to be? A line. Perfect. Linear. You're going to start up 3. And then your slope is 3/2. So you're going to go up 3 over 2. This is like welcome back to Algebra 1 class here. So up 3 over 2. Something like this. It doesn't need to be perfect. We are just getting a visual. That's it. What is this one going to look like? Just the shape of it. Like, what's the overall picture going to be? Parabola. It's going to start up 8, and it's going to be, yeah, like facing downwards. Why? Yeah, because of the negative. Perfect. All right, so we're going to go up 8, put a point. Now, I would only plug in even numbers because there's a 1/2 in there, and I don't want to plot things that are a fraction. So I'm only going to plug in even numbers. So let's do like 2 and 4. I think that's all the further we'll need to go. So if you plug in 2 squared, 4, half of that, 2, but it's negative. So -2 plus 8 is 6. Oh my gosh, that's where they intersect. Now you get the point on the other side. We're not actually really going to need that one, but you can put it there if you want. And then if you plug in 4 squared, 16, half of that is 8, but it's negative. So you get 0. And again, you can put the same point on the other side, but we really only need this half of it. You kind of don't need that half. This is the area that we're finding because it's enclosed by those 2 graphs and the x-axis. So the reason I wanted to go through one like this is you're going to have to split it into 2 separate integrals. I'm going to use my highlighter to show you this. Where is the split happening? At what x value am I going to have to, cut it like into 2 pieces? At 2. Do you guys see that there? At 2 is where it splits. So your first integral, and again, we won't work this one out. We're just going to set it up. Your first integral would be from where to where? -2 to 2. Good. And which function are you underneath for that portion? Which function is this one that I'm pointing to here? Yeah, the first one. So 3/2 x plus 3 dx. So that's the first one. Plus, and then what are your boundaries for the next one? Bless you. Get 2 to 4. And do you see how for that one, it's the parabola that we're underneath? Like that's this half. So I'm not going to make you do it, but you would have to do an antiderivative for this, upper minus lower, and then an antiderivative for this, upper minus lower. Do you see how it's two problems in one with a plus sign in between? Okay. I'm going to just keep going so that we can finish this and you can have more time at the end. Last thing that we're going to look at is called an average value. If I gave you a list of numbers and I asked you to please average them for me, what would you do? Add them all up, divide by what you've got. Leave a little bit of a gap here. Your integral from a to b f of x dx, that is adding up all the area. So that's like adding up your list of numbers. That adds it all up for you. You just need to divide by the length of the interval. So out front, you put divided by b minus a. That's the length of the interval. It's what we just got done doing, but with a little fraction out front. Here's what always happens at this point, though, is people mix up average rate of change with average value. And I 100% understand why that happens. So you have to be very, very careful with the wording of a problem. Just as long as you have reading comprehension and you slow down, you're going to be okay. But what is an average rate of change? Perfect, slope. You didn't even hesitate. And then an average value is this. They just usually don't use the word value. They usually make it a word problem. So they'll say average amount of grain, or like, because one year there was grain pouring from a silo, or they'll say average amount of paper. Do you get what I'm saying? Or like an average height of a person. Like they'll give an average something. It'll be a word problem. Do you get what I'm saying? Just gotta be really careful. So for this one, out front, you would put 1 over 3 minus 1. Do you see how your interval is 1 to 3? You have 1 over 3 minus 1, and then integral 1 to 3 of that function dx. So what really is that fraction that's out front? Yeah, that's 1/2. And now we're going to do our antiderivative. This is where the calculus is. Antiderivative for x squared. Yep. Cubed, good. They got there. All right, plus for 4x, 2x squared, such that 1 to 3. For the sake of time, like, I'm not going to do that, but you would have this 1/2 out front and you would do upper boundary minus lower boundary. Do you get what I'm saying? Like you would plug in the 3 to all of that, and then you would plug in the 1 to all of that. Do you guys understand? The point of notes is for me to do enough until you understand it. Have you got it? Because I don't get a lot of feedback from you guys, so it's hard sometimes. All right, for this one, out front, you would have 1 over pi over 2 minus 0. And then integral 0 to pi over 2 cosine x dx. You're just having to set it up. So what's really out front? Well, it'd be 1 over just pi over 2, which would really be 2 over pi. It's going to flip. Antiderivative of cosine. All right, you need a function that if you did the derivative, it equals cosine. Like cosine is your answer. It's just sine. Derivative of sine is cosine. That's just hard, like with the negatives and everything. It's just going to come from practice. All right, and then such that 0 to pi over 2. It would be upper boundary minus lower boundary. Like, I'm going to leave that. It feels like you've got it. All right, and then last one of these. You would have 1 over what? I'm going to ask you guys this time. How would you set it? 4 minus 1, good. Integral 1 to 4 of that stuff. Whenever there's a 2 in there, or any number for that matter, it always messes everybody up. So let me cover it up. What's your antiderivative of just 1 over x? You need a function that if you did the derivative, you would get 1 over x. ln. If I put that 2 back in there, it's just 1/2 ln. Do you get what I'm saying? That's all that it is. And so we've got that 1/2, and then what is that, a 1/3? Half times a third is 1/6. Why is there an absolute value there? You can't ln negatives. Good. And then you would do upper minus lower. The only follow-up question I'm going to ask is, what is ln of 1? Because you actually have to know that one. ln of 1 is 0. Okay. And then we're just going to do a couple where we're using the graphs. 4, 5, 6, and 7 go with this one. 8 and 9 go with that one. This will be quick and easy because we have a picture. All right, so for this one, it says from -3 to 7, so that's the entire thing, is -7.8. And I thought I gave you what one of the little bumps was. Oh, yeah, A is 2.3. So how could we find how much B is? Yeah, like this part's 2.3. You know, plus whatever this is, like 2.3 plus whatever B is, would equal -7.8. So it's going to have to be negative. What is that? -9 point, no, it'd be -10.1. And then you just use that to answer the question. What do you guys think about number 4? This is like review of what you did last time. From 1 to 7 would be what? Yep, -10.1. Number 5, from 1 to -3. Watch me point to this. From 1, which is right here, to -3, you're going backwards. Good. -2.3. From -3 to 7, but you want to treat it all like it's positive. So the whole thing, but treat it all like it's positive. $12.4. And then this is what we were doing today. Average value. Out front, you would put 1 over what? Yep, and I'm going to write it this way just to illustrate that it is subtraction. You can go ahead and write 7 plus 3. That's totally fine. And then it's integral -3 to 7 f of x dx. This actually does throw people off. You really don't even need the graph at all. They gave you this answer in the problem. This was given information, that part that I just put the pink rectangle around. What is -3 to 7 f of x dx? Because they did tell it to us. Do you see how that equals -7.8? That was given to us. So it's going to be 1/10 times -7.8. That last one is the same thing, except you'd have to find the areas yourselves, like break it into little triangles and rectangles and find the areas yourselves. Do you get that? Like it's the exact same thing we just did, but you would have to like be like, oh, here's a triangle and here's a triangle and here's another rectangle and find it. And then you could answer the question. Do you get what I'm saying?